This is Chapter 12 of Learning Web Design, which covers the many ways we can style text elements. It also introduces more selectors, including a couple that we alluded to in the video for Chapter 11. A lot of the chapter is dedicated to styling text, which is itself an art form. There's a bit of science to it as well, however. Usability studies have shown that the right text styling can make a website more readable, more scannable, and even set the mood for the user. Naturally, since typography is an art, designers tend to have pretty fixed font preferences. In programming, where the ability to see a lot of text at once is a real advantage, programmers tend to use dense fonts that work at small type sizes but don't leave a lot of breathing room around the characters. Graphic artists, on the other hand, tend to choose fonts with smooth lines that fit in well with the artwork. For some of them, readability and information density are afterthoughts. There are professionals who can help with this sort of thing, but even then, test out your typography with actual users to be sure that you're getting it right. Jennifer Robbins' first books were language references intended to catalog each and every nook and cranny of HTML and CSS. To keep such books as concise and precise as possible, most authors have adopted notation something like the one used here for CSS properties. The property name is given as a keyword literal. It's always exactly like it's typed. The possible values of the property are given as a list, with a pipe character separating the items. Why not use a comma delimiter? Because commas may be used inside list items. The pipe character avoids any confusion. Just as with the property name, list items can be keyword literals, which are exactly as shown. Often keyword literals are displayed in a monospaced font to distinguish them from other items that are not to be taken literally. These non-literal items are shown in italics, again to distinguish them from keywords. Besides giving the syntax for each property, the book also gives other useful information like default values, which element types the property applies to, and whether the property can be inherited. Here we see the various properties that control the font. As you can see, the values for these properties are a mix of keywords and non-literal instructions. The font family says what typeface can be used, either by name or by general style. We'll discuss font families a bit more in a minute. The font size has keywords for common sizes plus a couple options for more specific sizing. The rest of the properties are more or less self-explanatory, with only a very limited set of keyword options that can be used. One of the more useful techniques for font styling is the use of font stacks. A font stack is a list of font family specifications. Here we see Baskerville, which is used in the Fairfield University logo, Baskerville Old Face, etc., listed one after the other. The browser then tries each font, using the first one on the list that it can render. By listing a preferred font and then a bunch of backups, this gives the designer plenty of possibilities for progressive enhancement. There are 5 generic font families that can be used at the end of the font stack. Each of these has a keyword literal that is guaranteed to work in all browsers that support CSS. A serif font has decorative appendages called serifs at the ends of each stroke. Commonly used serif fonts are Times New Roman and Georgia. Sans-serif fonts like Arial or Open Sans lack the decorative serifs, and they have smoother stroke lines. Monospace fonts like Courier or Monaco are designed so that every character has the same width. These are useful in situations like coding, where spaces are used for formatting. Cursive fonts like the Comic Sans used and abused by PTA parents everywhere are intended to resemble handwriting, though they don't strictly have to look like cursive writing. Lastly, we have the fantasy fonts that are meant purely for decoration. You'd see these kinds of fonts being used on wedding invitations and church programs. I'm not a fan of fantasy fonts being used this way, but who can argue with tradition? Font sizes are given in standard CSS units that apply to just about every other element that can be sized. Besides the ones shown here, there are plenty of others. One can even specify the size of something as a percentage of the size of something else. We'll get back to that usage in a minute. The most common measurement units in CSS are pixels and ems. The others are more rarely used, with some like points being mostly archaic measures from hard copy printing, and others like VH, the viewport height, just now being introduced to support mobile devices. When talking about measures, it's important to keep in mind the distinction between absolute units and relative units. Absolute units are based on some sort of physical quantity that doesn't change. Examples are the px used to count pixels and the in used for inches. Relative units are variable, scaling based on the size of something else. The m unit changes depending on the font family, with some fonts being wider than others. As mentioned previously, the VH unit changes with the screen size to accommodate mobile devices. Similarly, percentage units specify what percentage of the inherited or default size that would otherwise be used. It's commonly used for sizing things like columns of a page, where each column takes up a fixed percentage of the page width, which itself might vary depending on the device. We'll come back to percentages when we get to fluid design techniques in Chapter 16. The book has this figure that shows the relationship between m units and pixel units. M units, shown as squares here, always equal the height of the font at the inherited font size from the tallest ascender to the lowest descender. The name comes from its old definition in print shops, where it was the width of the capital letter M. However, we now use the letter height instead to accommodate non-Western languages that lack the letter M. As you can see, one M changes from 12 pixels on the left to 24 pixels on the right. This can be pretty handy in some situations where you want the text to scale in a natural way as graphics and other elements change. Percentage units work similarly, only they're not tied to inherited font sizes. Rather than specify all the properties of a font one at a time, which can be pretty tedious and a bit verbose, one can and should use the font shortcut property that combines them all in one declaration. A font shortcut always follows the same pattern, with the properties given in the order shown here. At a minimum, the font shortcut has to specify the size and font family in that order. The font family can be a font stack if desired. The book has a lot more to say about the font shortcut property. After the font options, the book provides a lot of reference material for other properties to handle things like line spacing, colors, indents, and decoration. Again, these are described in detail in the book. There are also plenty of online references you can consult to understand all the options. The second half of the chapter switches over to focus on three very commonly used selector patterns. Descendant selectors and their cousins, the child and sibling selectors, are based on the location of an element within the element tree for the document. ID selectors are used to give pinpoint control over individual elements within a document. Class selectors are used to apply styling to groups of elements that have each been tagged as being members of the class. Descendant selectors choose elements based on their ancestors within the element tree. The ancestors to look for are given, in top-down order from the document root, as a list of simpler selectors, typically by element type, though other possibilities exist. Here we see the selector looking for a link, the A element, inside a list, the LI element, inside a navigation menu, the nav element. The last selector in the list is always the actual element being selected. The others are just there to indicate its ancestors. Note that we're using the word ancestor and not parent. An ancestor does not have to be an immediate parent. However, selectors that list the immediate parent, grandparent, etc. are more specific than those that specify only distant relations. This is just as we'd expect. After all, I'm sure we've all got some royal blood in us, but that probably doesn't have much bearing on our lives today. This figure from the book illustrates how descendant selectors work. The selector LIEM on the left is matched up with elements in the tree to find two matches. There are two other EM elements in the tree, but they don't have LI elements in their ancestry. If we wanted to use a few more distant ancestors, we could, though our rule would lose out to one with a more specific selector. The book spends a little time on two more variations on the family tree theme. Child selectors are a way to specify that the ancestor is the immediate parent of the child. The notation uses a right angle bracket or greater than sign to indicate the parent-child relationship. This is just a more specific kind of descendant selector and can be useful when there are deeply nested elements like nested lists with similar element types at each level. Sibling selectors aren't really a special case of the descendant selector. Instead, they're based on which elements appear near each other. Sibling selectors aren't used very often, so it may be better to study them in a CSS reference when you come across them. All you need to know right now is how to recognize them. The plus signs and the tildes are dead giveaways. ID selectors are the most specific kind of selector. They indicate exactly which element is desired by stating its ID as given in the HTML attribute of the same name. The syntax for ID selectors is a hash followed by the ID name. After using them for a while, you start to treat them like a special kind of element, the intro or the toolbar. This figure from Chapter 11 shows two examples of elements that can be selected by ID. As you can see, each is unique, appearing only once in the document. Once we specify what ID we're looking for, the element type or other aspects of the element generally don't matter. It either matches the ID or it doesn't. We can use ID selectors with element type and descendant selectors to provide alternate rules depending upon where the element lies in the tree. These compound selectors act to make the selector even more specific than the ID alone. If we provide the element type followed immediately without a space by the ID, then we're asking for an element of the given type that also has the given ID. If the element has the right ID but the wrong element type, then it doesn't match. If we have a space in front of the ID preceded by another selector, then it's descendant, and the usual rules for descendant selectors apply. We can also use the ID as the ancestor in a descendant selector, meaning that the selected element has to be a descendant of the element with a given ID. Our third kind of selector is by class. Like ID, the class of an element is set using an attribute in the HTML. In the CSS, class selectors are written as a dot followed by the class name. Since classes can be used as many times as we like within the HTML document, they're not as specific as IDs, which leads us to our last topic of the chapter. Like the cascading rules about CSS source, browser to user to external to embedded to inline from Chapter 11, we also have rules about selector specificity. The least specific selectors are by element type. These are trumped by descendant selectors, which can become more specific depending on the ancestor specified. Descendant selectors are then trumped by class selectors, though a combination of class selectors within a descendant selector is even more specific. Finally, the most specific selectors are those for IDs, though once again we can mix them into descendant selectors to make these even more specific. The rules can get pretty complicated, making the right choice of selectors for any given rule somewhat of an art learned through trial and error. That means practice, with as much time as possible spent debugging complex web pages. It's tempting to just always use ID selectors. In fact, that's what most newbie designers tend to do. That's actually a pretty big mistake. Generally, we want to use the most general rule, classes instead of IDs, descendants instead of classes, etc., that we can, that we think will actually work. That'll give us the flexibility to make more decisions later on that we can apply using cascading and inheritance instead of tediously rewriting lots of redundant rules. We'll consider these and other considerations in the chapters that follow. Thank you for following along with Chapter 12 of Learning Web Design. See you later.